of times you'll hear the kids go, oh, okay, so now we're using the algebra to bring home the add-ins. Look, look how far we haven't gotten, right? We're still at add-ins. We're still at 4. That's what I mean. When you're working with other kids' or other parents' kids, and you throw in that, nobody's showing a 6-year-old or a 7-year-old algebra, and it's worth money. Don't just charge $5 an hour. It's ridiculous. Don't charge $10 an hour, right? What are they trying to get? McDonald's guys making $11 an hour? You are imparting knowledge that is not readily available. It's worth $20, $30, $40 an hour, right? Now, I understand that in the area you're in, that's the common man is no longer able to afford that kind of, rate per hour. So you might have to have 2 or 3 kids at the same time, right? And you lower it down. So now you've got 3 kids, each paying 20. Ooh, now you're making $60 an hour, right? But each parent is only paying $20 an hour. And I know parents on Maui that used to give me a hard time, like, you should leave your rate at 50 and then we'll break it up with 5 kids and we each pay 10. Okay, good. Go find somebody that'll do that, because I'm not. Right? That's what it costs. You know what I mean? Okay. And I make no apologies for it, because they're not getting this anywhere else. Period. Okay. And this is super effective for shortening the time frames. Okay. So then you can add more, right? Then we can make bigger ones. I'm just going to draw it because I don't want to spend the time taking it out. Right, so there's 2x squared, 6x, and 4. And it helps, right? Because it's adding more, right? And we can see that this is 2x squared. Count the big ones first. These are the x's, 6 of those guys, and 4 units. And my factors are 2x plus 2 and x plus 2. Right? And then you can flip the blocks over and do a base 10 lesson, but that's a whole other thing. Okay. So, right, I mean, there's so much you can do every day. It is limited only by your imagination. And again, the lessons don't have to be an hour long. If you can engage them for an hour, great. But sometimes, like even with my, when I'm doing video tutoring online, sometimes I'll stop at 50 minutes because we ended on a high note and I don't want to do more. I don't want to develop more. So you want, like I said, always leave them wanting more. Always try to stop, and because for you also, what you want to do is you want to have positive association, right? That's why we have the smiley face books with mathematics. That's so important, just that part right there. If they can just associate, right? Because I had kids that and a lot of times what happens is like there's a little switch in their head, and if the switch is over here and the minus and the negative, then it doesn't matter who's teaching them or what it is. If they think they can't, and they don't want to, and it's no fun. And then if I can flip that switch over here, right, over to positive, suddenly I'm like this genius guy, and I'm a magician when it comes to math. But no, all I did was change their thinking to the fact that math is fun and easy. And now once they think, oh, I can do this, and they can, because they can speak English, they can do math, now anybody can teach them. Now they go back to public school, and it doesn't matter. Crappy teacher, good teacher, whatever, they can get it because because their thinking is, I can do math, I can do this. Right? Because walk into anything thinking that you can't do it, right? Walk into your marriage thinking that I can't stay committed. We'll see how that works, right? Okay, same thing. If you go in thinking, all right, this is going to work, this is going to be the greatest thing ever, and this is great, it's a great decision, blah, 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 you're good, right? Doesn't matter what it is. And this is that's a life lesson I tell my kids all the time, is you get to be right? It's set up perfectly. You get to be right. If you think you can't, you're right, you can't. If you think you can, which is the better choice, you're right. Although there are some times when, if you're on a bridge and you think you can fly, it's probably bad. But, but you know what I mean? There's got to be some discretion in there. But anyway, you get the idea is that if you think you can, you can. Especially when it comes to like adding numbers together or fractions or something, right? Right. Okay. Like I have one student where he just absolutely had made the decision that he couldn't learn this. And I couldn't flip the switch. And he quit coming because he just absolutely wouldn't do it. All right, well, you know what? You can't get them all. Doesn't mean the system doesn't work. Just means that for that kid, didn't matter who it was. Right? Sorry. And see, teenager. If I would have caught that kid when he was 6, never would have had the problem in the first place. Okay. I'm going to leave you with this, because you know me, I can go for hours. Literally, like we can go for a long period of time. First things first, you want to start in the concrete. I'm going to move to one more thing. Put it here so I don't forget. So I don't go tangential. You want to start in the concrete every time. You start with the blocks every time with your kids, right? Sometimes I have to start with symbols, right? Because if you are an adult or if you are an older student, math is symbols. Math is not blocks. I've had college kids come in and tell me, you know, I mean, they look at the blocks and like, I'm a college student. What do you mean? I'm like, and yeah, you're going to get your hands on the blocks, and for the first time in your life, you're going to understand factoring polynomials, right? Okay. And I've had engineers and guys with degrees in math and physics and all kind of telling me, oh, for the first time, they see all that stuff that they didn't have trouble with, right? Because these left brain guys, no problem. They just memorize it and they're good and they can apply it and use it and so forth. But a lot of the right brain, right? And we're finally got to the point where we're starting to realize that you two, husband and wife, looking at this presentation, you're seeing two different things, right? Because a woman's mind works differently than a man's mind works. We can prove that now. So we should teach to the learning style. We don't have what, right? This works for everybody because it gets the whole brain involved. But a lot of learning stuff, or a lot of learning or teaching methodologies teach for the male visual mind. Well, what if you're not a visual learner? What if you're a kinesthetic learner? Well, you're screwed, that's what. Right? What if you're a female with a more creative, intuitive mind and you're more of an auditory learner? Well, guess what? The male visual isn't going to work very well for you. Right? Okay, so we need to figure out what that child's learning style is and teach to that style. And it's, how is this heresy? How is this even, it's 2014. How is it possible that this is like radical thinking? It just makes sense, right? And what we have is built a system where here is the square hole and you're supposed to put the round peg in there and the star in there and the triangle in there, and if it doesn't work, shave it and just stuff it in that hole, right? And it's not working. It's obviously not working. Okay, so anyway, you start in the concrete. Move to drawing actually should be the next stage, right? So when I have x squared plus 3x and 2, this is not where I start. I start here, and when I talk about concrete, I don't even have symbols. When my boys first started factoring polynomials and when we were kids, they just got out the blocks. We didn't even write stuff down. Right? Just get these blocks out, make me a thing. Okay, so then later on I might say with the older kids, here's the code. And then we do the, you know, the association 3-period lesson where they understand what this is and what this is and what this is, right? Okay, so then we move to drawing. So here is x squared, 3x, and 2. And by the way, that can also be multiplication. 11 times 12 is 132, right? Base 10 lesson. And I could put it down like this, and now I've got a division problem, right? Okay, but there's my drawing. So what you, ideally, when you're working with the little kids, start here, go here to drawing. Okay, then to the symbols. Then you can go from the symbols to the concrete and so forth. And what you get here in this triangle, they go back and forth all the way, right? They're able to take the concrete and the drawing and the symbols, and you can get the three of them together. And I'm not going to spell it right. Abstraction.
You did it.
Right? The combination of these three. Because math, even, I mean, we can get really esoteric. I've been to number 3 classes and talk about 3 what? What are we talking about? What is 3? You know? So you want to make it concrete. Or you can, you know, you talk about various concepts in mathematics. It's very abstract. You should put a label on it. Because, like, 3 what? 3 miles? 3 hours? What are we measuring? What are we talking about? Right? Okay. So right there, have you put this in your notebook or whatever? Because this is huge. Can't even express how huge this is. And you know what? This will be probably the first video in a long time. I don't even have this, I don't think, on my website at the moment, and it should be. Okay. So, but this is, because again, it's the theory, then you understand where you're going while you're playing these games and you're doing stuff, right? Is that this is what you're doing. You're starting to concrete, this is why. And then you move the drawing, then you move the symbols, and as time goes by, they will begin to do the abstract and be able to see, right? Okay, so then the next step, and we'll stop, is multiplication. The huge milestone in mathematics. Okay, but again, it's concurrent, right? You start here, right? Multiplication, and then the way they teach it in school is going to be the next thing is going to be division, and then the next thing is going to be fractions and decimals, and then maybe some percentages, right? And then they're going to introduce some algebra or geometry, depending on what school you're in, and then they're going to do algebra 2, and then they're going to be trig, and then they're going to be pre-calculus, and then they're going to be calculus, and by the time they get there, it's a meaningless dance because all it is a bunch of formulas and stuff that you memorize, and none of it makes sense, and it's just so compartmentalized, and they teach you algorithms, do this, do this, do this, do this, and if you forget the algorithm, you're screwed. And most people, and I was talking to a guy, has a degree in mathematics, memorized long enough to take the test.